Welcome to your video stream for 8.4 Metamorphic rocks. Sorry I couldn't be there as I'm away, but I hope this will be informative for you guys. Have a look at this picture here. This is a picture of some metamorphic rocks, and hopefully when you look at rocks and landscapes you'll be able to identify them as well. So let's start. Igneous and sedimentary rocks can be altered to form a third type of rock known as metamorphic rock. Make sure you fill out your notes here, metamorphic. Sometimes these rocks are very brightly colored and may contain precious minerals. Metamorphic rocks also weather, and break down into smaller particles. This cycle of never-ending changes in rocks is called the rock cycle. Now, the formation of metamorphic rock. Metamorphic means the rock has changed form. So think of metamorphosis, like a butterfly and a caterpillar or butterfly. It undergoes metamorphosis. So metamorphic means the rock has changed form from its original form. Metamorphic rocks form when high temperature and pressure alter existing igneous and sedimentary rocks. So you might get an igneous rock that's come out of the ground, it's extrusive, but then it might have high temperature or pressure again from the earth, and it will alter it to be a metamorphic rock. Metamorphic rocks can also be formed from other metamorphic rocks that have undergone high temperature and pressure as well. And we just look here. This rock here is called garnet, and it's gone under intense heat and extreme pressure. And it can be physical or chemical, and when it is under extreme temperature and pressure, it can have new minerals form not seen in igneous or sedimentary rocks. So garnets and the precious gem sapphire and ruby occur in metamorphic rocks. Let's look at the type of metamorphism and how it occurs. Metamorphic rocks can be formed from below the surface as well as in the crust near the surface. So this is the crust here, or well below the Earth's surface down here. Firstly, pressure and heat from moving tectonic plates can form metamorphic rocks below surfaces. So tectonic plates are like two land masses, and these plates are rubbing together. And this is how volcanoes and tsunamis and earthquakes happen. So tectonic plates are, the Earth is on kind of like an eggshell, which is like tectonic plates all around. And when they rub together, it creates pressure and heat from those plates. So there's one way with tectonic plates, or rocks can also, that come in contact with hot magma, as it pushes through the crust, can also become metamorphic rocks. So this here is the second part, which is the magma, and this here is called regional metamorphism. So regional metamorphism occurs over a large area, and it includes the tectonic plates. Contact metamorphism is metamorphism over a small area, and this is when it comes in contact with the magma. So regional, think of large regions, with tectonic plates, and contact with small areas with magma. Metamorphic changes. Metamorphic rocks can also have many different minerals compared to igneous rocks. This is because heat and pressure can melt rock, causing a process called recrystallization, when new crystals grow as the rock cools down. When the rock is molten, the particles can move around and new minerals form in this process. Diamonds can be formed in metamorphic rock when parts of the Earth's crust become pushed into the mantle, which is the hot magma. High temperature and pressure in the mantle change the rock, and at temperatures of about 1000 degrees, the carbon in the rocks crystallize to form diamonds. And the diamonds are carried back up millions of years later, or thousands of years later, by a rising magma, and then the magma then solidifies around the diamond, meaning that diamonds are found inside igneous rocks even though they weren't formed there. So have a look at this diamond here. It's actually unestimated because it's too expensive. No one knows how much it's worth because it's priceless. It's the largest diamond in the world. So it was originated at Golconda in India, and now it's there's some which are a bit larger than it now, but it's one of the largest ones in the world, and it's currently held in a museum. Metamorphic changes. So you might get something called foliation, okay, and it's a process where mineral layers in rocks can be squashed into layers. Okay, so minerals in rocks can be squashed into layers, and have a look at this one here. It's a really great example. Gneiss. That is called foliation. When you see all these banding up and down, that's called foliation. When you see the layers or banding in rocks. The amount of banding depends on the amount of heat and pressure. Okay, you may need to pause this so you can write your notes down. But let's keep going. Not all metamorphic rocks show bands. Metamorphic rocks without bands are known as non-foliated or unbanded. Okay, and these are some here: quartzite, hornfels. These are rocks which are metamorphic but don't have that banding. Now, later on you'll come back to this diagram. In your notes, you'll see in your textbook there are different uses, and I want you to write just 2 dot points for each of these notes. Now, don't do this yet, okay? You can do this after the end of this video, but you'll go back and read about this and just write 2 short dot points, please, okay? Nothing too much. But I want you to go to this picture here on the last page. It's called the rock cycle, and it kind of ties everything in together. We've learnt about 3 types of rocks now: igneous, sedimentary, and metamorphic, and they all intertwine together based on metamorphism or weathering. Okay, and let's look at the rock cycle here. So first of all, we have igneous rocks. Now, when an igneous rock undergoes heat and pressure, it becomes metamorphic rocks. Okay. When igneous rocks go under weathering and erosion, it becomes sedimentary rocks. Okay. So, igneous rocks will undergo melting and cooling as well. Okay. In magma. So, if an igneous rock melts, it becomes magma. And if magma cools down, it becomes an igneous rock. Now, if igneous rocks weather or erode, it becomes sediments. And if metamorphic rocks, if they start to weather or erode, they become sediments. Now, if sediments undergo compaction and cementing with natural cements, you get sedimentary rocks. And if sedimentary rocks undergo heat and pressure, or if igneous rocks undergo heat and pressure, they both become metamorphic rocks. So I hope you can see this picture here and fill out the notes for yourself. You will be expected to know the rock cycle and label something like this here. So have a good look at it and see if you can get your head around it. So that's the end of the notes for metamorphic rocks. Try to aim to do your unit review for 8.1, 2, 3 and 4, which will help you for your test revision. And you've also got your AB books to look at if you've got any extra work to do. And if you've done all that, there's always the chapter review questions. Remember, just do the remembering and understanding questions of the unit review, and if you want to go further ahead with chapter review, you can do all of them, but I don't want you to be overwhelmed. This is just a good start. So I hope you guys have enjoyed it, and I'll see you next time or next week. Thank you.